this theorem, you take the derivative of r of t, that's tantamount to take the derivative of f of t That's good. That's good. That's good. Thank you. Y'all gonna make some good husbands. Are you married already? Yeah. How long? We won't say. Okay, we won't. We won't tell her. What you say? We have to think about it. You know. Pardon me. They do. They do, and they will get you if you don't know it like that too. You know. That's right. I try to drop my books or something, you know, give me time to think. Yeah, let me pick this up first, baby. You know, man. 21, you know, 22. Yep. So find the derivative of r of t. You just find the derivatives respectively of the individual functions. Here, the result of the derivative is still a vector value function. It's still I, j, and k. The same thing for the integral as well. The properties of the derivative, the same properties from calculus 1. So integration, again, when I integrate r of t dt, I integrate f of t, g of t, and then if it's in the space, I integrate h of t. Let's look at some problems. So here, find the derivative. We can rewrite r of t as t to the 1/2 I plus 1 minus t to the 3rd j. So r prime of t becomes 1/2 times t to the 1/2 minus 1, or negative 1/2 times I. And then this is minus 3t square j. And you could just write that as 1 over 2 times the square root of t I minus 3t squared j. Just straightforward derivative. Okay? All right, find that derivative. Give you about a minute to do that. We should be able to finish this section before today is over with. Don't forget to apply the chain rule, right? Remember the chain rule or the power rule? Did you get that? Negative 9 cosine squared t sine t I plus 6 sine squared t cosine tj. Okay? Brother Lewis, did you get that, man? Good, good. All right. Okay, for this one, let's see. I'm going to rewrite this r of t as 4 t to the 1/2 I plus, this is t squared times t to the 1/2. So this is t, this guy is t squared times t to the 1/2. So you can write that as one term and just take that derivative one time. Bless you. Or you can use the product rule, but then after that you still have to simplify and use algebra. So let's just deal with it right now. This is t to the 2 plus 1/2. So that's t to the 5/2 times j plus the natural log of t squared k. So then we find r prime of t. So this is the 4 times the half times t to the negative 1/2 I plus 5/2 times t to the 5/2 here minus 1, or 5/2 minus 2/2. That just gives us 3/2 j plus, you remember the derivative of the natural log is 1 over the term times the derivative of the term. So this guy becomes 1 over t squared times the derivative of t squared. That's just 2t, and that's times k. Then we just simplify everything. So we have r prime of t is equal to 2 over the square root of t I plus 5/2, just leave that as t to the 3/2 j plus 2t over t squared is just 2 over t times k. Okay, is that okay? Okay, now it's your turn. I will sit down. So hopefully you got this. And again, I do not like the notation that he uses with those V's on the outer side because they actually denote inner product, dot product. But anyway, um, sine t plus t cosine t, comma, cosine t minus t sine t, comma, 0. Sure would. That's right. It's supposed to be a 1 there. I tell you, it was about 11 something last night when I was doing that. And oh man, yeah, it's rough on me. You're exactly right. Well, I guess that's good. That was the only one that I missed. I didn't miss the hard stuff. So you didn't miss the easy part. Oh boy. Okay. Thank you. Bless your heart. Now let's talk about integration. So here we integrate the individual functions. So basically we're doing this. We're integrating the 4t to the third dt, and that's times I and then plus the integral of 6t dt j plus the integral of the negative 4 times the square root of t dt k. So this is 4 times the integral of t cubed dt I plus 6 times the integral of t dtj minus 4 times the integral of t to the 1/2 dt k. So we integrate here, we get 4t to the 4th divided by 4I plus 6t squared divided by 2j minus 4t to the 1/2 plus 1, that's 3/2 all over 3/2 k, and then plus the constant c, and then just simplify that. Well, that's a 4 there. So this is just t to the 4th I plus 3t squared j minus 8/3 t to the 3/2 k plus your constant c. Okay. All right, you work this one. Did you get the natural log for the first part? Good, good. Okay, let's see if you got this. So the natural log is supposed to be the absolute value of t, but for this interface, Smart Notebook doesn't have absolute value. But natural log absolute value of t times I plus t times j, and then minus 2 over 5 times t to the 5 over 2 power times k plus c. Okay. Good. All right. Any questions there? The integral of the secant square Yes, sir. So because the derivative of tangent is secant squared. So here we get tangent ti plus the integral of 1 over 1 plus t squared dt is what? Tan inverse. Just something to remember. Right. Now here, this is a definite integral. So let's see. So first we're going to simplify that third term. So this is the integral from -1 to 1 ti plus t cubed j plus t to the 1/3 k dt. So we integrate. We have t squared over 2i plus t to the 4th over 4j plus t to the 1/3 plus 1 becomes 4/3 all over 4/3 k. All that's evaluated from -1 to 1. Just simplify this one more time, that third part in particular. So this is t squared over 2, t squared over 2 I plus t to the 4th over 4j plus 3 over 4 times t to the 4/3 k, evaluated from -1 to 1. So we first evaluate at 1. So we get 1/2 I plus 1/4 j plus 3 over 4 k. Then that becomes minus. Evaluate the t at -1, so that's 1/2 I plus -1 to the 4th is still 1 over 4j. This was minus. And then this is minus 3 over 4, and then t to the t is -1. We raise that to the 4th power, it becomes +1, and that's the cube root of 1 is 1, so that's just k. So let's see, the 1/2 I minus 1/2 I cancels out, 1/4 j minus 1/4 j cancels out, and 3/4 k minus 3/4 k cancels out. So we just have 0. And, well, that's our time. I think that last problem was a class assignment anyway. I'll post this in Blackboard, and so you can play around with that, do the homework for these 2 sections.